Hello everyone, my name is Aviad Almagor. I'm the director of the Mixed Reality program at Trimble. And I'm delighted to be here actually. A year ago, AWE 2015, we presented here the proof of concept we did with Microsoft on the HoloLens device. It was an exciting time. New technology, new piece of hardware, amazing potential. This year, AWE 2016, it's even more exciting. From proof of concept, we moved to products. And from searching for use cases, we're actually working with customers on real projects. And I would like to share with you in this 15-minute session our experience regarding those pilot projects. For those of you who are not familiar with Trimble, quick introduction. Trimble is a global company, about 8,000 employees, $2 billion in sales a year, presence in about 150 countries around the world. We are developing hardware and software. On the hardware side, think about positioning devices, scanning devices, RFID, drones, total stations, laser scanners. On the software side, it's about end-to-end solutions. So if we'll take, for example, the construction industry, we have design tools like SketchUp and Tekla Structures. We have project management solutions like Vika Office and Prolog. And we have facility management solutions like Manhattan, so covering the full life cycle of a project. We have a pretty diverse portfolio serving industries like geospatial and mining, and agriculture, building, architecture, construction, facility management, oil and gas. And not surprisingly, for all those industries, we provide the solutions to capture data, create data, analyze it, and communicate it. And we really see mixed reality as a critical ingredient in this kind of workflow. And this is why we created the group, the Mixed Reality program, which provides a kind of infrastructure, a platform for all those markets to perform for our customers. So in the last year, we kind of joined several customers, kind of visionary customers, like Gensler, who are sitting here and will join us tomorrow, Martin Brothers, Greg Lynn, AECOM. And we were working together with them on exploring the potential of this technology. We're developing solutions which are hardware agnostic and operating system agnostic. Yes, we are partnering with Microsoft on the HoloLens. It's a great device. I think the best today regarding wearable see-through device. But there are other tools around, and each one of them have its own capabilities and advantages, and we would like to make sure that what we deliver to the customer is tuned to his needs. And during the work with the customer on those pilots, we identified several themes which kind of represent value for the customers. It's about real 3D. It's about closing gaps and context-driven workflow. And I would like to explore a bit about those three. So starting with real 3D, our customers have beautiful 3D models today, very detailed model, but they're still consuming this data like they did for the last 30 years behind 2D flat screen. We realize that once we take this data out of the screen into the physical environment around us, the customer can much better communicate their design ideas with other stakeholders, can accelerate design processes and review processes. And in fact, if we are looking at this virtuality to reality continuum, we see mixed reality as a leading technology. We have VR and AR and MR. And specifically for our industry, VR is almost like a genetic error. It's kind of a very limited set of use cases which we can support with this kind of technology, with virtual reality. And again, for the industries we serve, not necessarily for other industries. And we see mixed reality as the biggest potential to provide this kind of real 3D content in the physical environment around us. The second topic is gaps. And this is actually a pretty sad story. When my kids ask me about the color of my hair, my immediate answer is black. And this is certainly not the case anymore. But this is a mental model that I have. And there is a gap between the mental model and the reality. Now, this is an easy problem, and probably a mirror will solve it. But I would like you now to imagine a big mine, or a construction project, or a huge hospital. Imagine thousands of people walking around, each one of them with his own mental model about the task that he needs to perform. This is already a big problem. In fact, this is kind of catastrophe. And this is what's happening today in many of our industries. We believe that mixed reality can bridge this gap, can bring together mental models and reality, physical environment and digital environment. And the third topic, which was mentioned earlier, is about data in context. When we started to work on the facility management solutions, we had this dream of let's bring the BIM model into this environment, and this will be beautiful, and IoT will be automatically presented. But then we realized that in 98% of the building that we are serving, that our customers are serving, there are no models. In fact, we are lucky if there are drawings. So we're looking for ways to connect the physical environment with a huge digital content we already have. And what you see here is the ability of the team on site to create this link. And once this link is created, it is maintained automatically. So next time I'm in this space, I will be able to see the data in the context of the physical environment and to get the information that I need to perform my task. So 3 themes: the real 3D, bridging the gaps, and data in context. If we will implement mixed reality technology in the right way, we believe that it will really transform the way the industry is working, the industries that we are serving. It will change the way our customers communicate and consume and interact with data, and change them from kind of information communication to experience communication, which is a great step forward, much more effective way to interact and communicate data. So let's see what some of our customers are saying, and I would like to pick 2 here, and we'll have, as part of the keynote tomorrow, Gensler point of view on the process. And we can start with AECOM, the biggest engineering company in the world today. While working on the mixed reality technology and while kind of experiencing the workflows through the pilots, they really realized that using the real 3D content in the physical environment allows them to accelerate design review processes, and at the end of the day, provide better quality product to their customers. What you see in this short movie here is a team of engineers from the AECOM doing what we call the Colocated Collaboration, in this case using Microsoft HoloLens. And are working around this kind of digital model in real 3D. They can change the scale it up, scale it down as needed. They can visualize it from any position they want. They can play with the layers and expose hidden component. And they can really understand what the meaning of any design change on the final output. They can analyze the structural aspects as well as the kind of aesthetic aspect of this design and communicate those aspects with other stakeholders. We can support this same scenario with remote users. In the case of AECOM, most of the projects involved remote users. So they can see and share the same content on the table, each one of them in his own office, and communicate together and get to the right conclusion together in a much more efficient way. The next use case is Greg Lean. Greg Lean is an architect. Actually, he's a star architect, what we call today. We were working with Greg Lean on a project for the Venice BL. I came 2 days ago from Venice. We presented with him the result of his work. Greg was picked to represent the US in this event. During the design work, he was using our mixed reality technologies to visualize and understand his design decisions, check for design alternatives, and communicate the design with other stakeholders in the team. And again, for him, the main value was the ability to bridge this gap between his imagination, his ideas, and the real world in a very efficient and fast way. Let's take a look at a movie that was created by Microsoft around this project.
By the American Pavilion at the Venice Biennale of Architecture to be imaginative and show what's coming with architecture. And we were given a mile-long building in Detroit that's been abandoned for 50 years to use our imaginations on. The Packard Plant is one of the first Albert Kahn buildings, and it grew from 1906 to 1956, exploded in growth, and then was abandoned. The way we started the design is we went to the site, walked around, also flew drones, and matched that drone footage to our digital files. I'd known about the Trimble Microsoft partnership on the HoloLens and was just itching to find the right project to do a pilot with it. So we built a model, but we used HoloLens to bring the model to life. Microsoft HoloLens is a wearable computer that lets you see holograms mixed with reality. With Trimble Connect, I can look up and grab different buildings to compare. I didn't know how big our site was compared to corporate headquarters or museums. We could just pull a model and duplicate it and see that it would take 12 Tate Moderns to fill the site. That brought it to life in terms of use. Microsoft HoloLens lets us get inside stuff earlier and experience it, and I can look up and see the volume that I'm in and start to make decisions about how to design it. Without a HoloLens, I would have been making those decisions 3-4 months from now. But with the HoloLens, I'm making those decisions at the moment of inception. In the redesign of the Packard Plant, showing the dynamics is something that's very hard to do. HoloLens immediately solved that problem, and it explained why things were the way they were because they were meant for vehicles and people to move around. I've spent my whole life trying to get things from geometry into the physical world. HoloLens is going to bridge that gap between the two-dimensional and the three-dimensional and physical space. And that's architecture. It's a revolution.
About 30 years ago, a guy named Bruce Chatwin was walking in the desert in Colombia. And he encountered this old lady. She was carrying an aluminum ladder, walking in the desert, putting the ladder, stepping up, looking around, stepping down, a few more steps, doing it again. Apparently, this lady was Maria Reich, a German geologist, and she was researching the Nazca lines, those beautiful shapes in the desert. And I'm telling you this story, and you can see those shapes here. I'm telling you this story because I believe we are in kind of the same situation with our technology today. We are dealing with customers, with real project, with a new technology. We are pushing this technology to the edge. It's not always fun. Sometimes it's painful. We are searching for ways to provide solutions. You all know what it is because you are in this environment as well. And when you're dealing with the day-to-day activities, you sometimes might feel frustrated. But if we will take some steps up this ladder and look at the horizon, we can clearly see the pattern. We can clearly see where this technology is taking us. And I think this is going to be a very, very exciting year. So thank you very much.
Thank you, Aviad. Okay, we have one more presentation for you today, which was going to round off our day here. The last presenter, I'm happy to introduce Peter Verstraet. He is the Chief Executive Officer of Prosedics, and his talk today, I think this may be a placeholder title. No, it's the right one. Role of Augmented Reality and IIoT for Work Instructions. Welcome, Peter.
Thank you. Good afternoon, everyone. I will be telling you a little bit about instructions. Just as a background, our solution, Prosedics, is a cloud platform to manage the content of work instructions and procedures, which are then executed either by mobile technology or by wearable devices like Google Glass or smartwatches in combination with a mobile device. My background is in manufacturing and logistics for about 20 years, and that's the perspective that I will be giving. And maybe as the last presenter today, I might end with a few pragmatic notes. Let's put it this way. When we are discussing instructions and what you need for instructions, it all depends. And it's hard to make a general statement. So I put this formula a little bit inspired on a Lean Six Sigma approach. What you need in terms of instructions is a function of influential factors. And those influential factors is the industry, for example. In some places, you cannot touch a device, a Google Glass or any other device on your nose because your hands are dirty. In other places, you can't touch it because you're in a lab and you might contaminate stuff. So it's a totally different game bringing instructions to somebody in such an environment. But then also the operator, the tasks he's performing, the profile he has. Some people are masters in engineering and other people barely can read. And you need to bring instructions to these people. The process is an influential factor. So all of these elements influence what you need in terms as instruction support. And what is also important, when I'm talking instruction support, I'm not talking machine-to-machine communication. I'm talking an individual that is involved in the process and possibly interfering, or most of the time interfering with machines. But it's the human interaction that is key, and it's that human that you want to guide with instructions. And then the challenges of instructions, and there I agree also with what has been mentioned earlier today, is that the instructions, the challenges that we are facing is a function of the needs, and in some cases simple needs, in some cases quite complex needs, and the technology. And I would dare to say that technology constraints are the source of most of the challenges we face in instruction support today. If we take an example of, and I'll take that example along the presentation, if we take an example of a technician, by the way, a technician is not to be compared with somebody from quality control or with an operator in a process industry, is not to be compared with an operator in an assembly operations. But let's take this technician. He basically does 3 things in a day. He does repairs and maintenance. These things are typically managed in SAP plant maintenance, in Maximo. It's shutdown type of stuff, revisions. You need spare parts. You need sometimes contractors helping you out. You need to organize all that. And it's most of the time managed by a computer maintenance system. But then next to that, the guy is doing checks twice a day, twice a week. He's walking around and he does a temperature check here, pressure check on a compressor every day or twice a day. And he's not managing that in SAP. Far too complex. He just walks around with his logbook, writes down or print on a printed paper, does his tour, and fills out the form every day. And then there is a third level of activity he has. Once in a while they call him, and they call him from the manufacturing floor because they're doing a changeover from, let's say, a 50 centiliter bottle to a 25 centiliter bottle. There need to be 30 tasks performed, 26 by the operators of the machine, flushing the pipes, to give one example. But then for certain tasks like changing the robots, they need to call in the technician, and there again, he drops in 15 minutes, 1 hour, not managed again in SAP, just helping out his colleagues on the operational, on the work floor and making sure that everything happens the way it should be. That's the life of a technician. And I like the statement earlier today again of somebody that said, if you want to talk how we gonna help people, we should walk with these people and really understand what they're doing. And this is exactly what I try to highlight here. Now, okay, we know what he does. Next thing is, how are we going to make sure he does what he has to do and he does it right? There we have, if you talk instructions, it's a broad scala of things. You have standard operating procedures. It's the text blah, blah, blah that tells you what needs to be done, who needs to be there, why it needs to be done, and it certifies that you got an ISO certificate. You use these documents to introduce new people, but I would say basically you're supposed to know what is in these documents before you walk onto a manufacturing floor. Then the second, most of it is, by the way, in Word. I would dare to say 95% is Word-based in companies. And then the second level of instructions is work instructions or inspection instructions. They tell you something different. They tell you a specific thing, how that task, activity exactly needs to be done. You open this, you clean it out, you replace a filter, and most of the time we encounter Excel sheets where there is step-by-step blocks with pictures, and they tell them how it should be done. And then the third, because whatever we say here today on augmented reality and on very advanced technology that has tremendous potential, but reality is manufacturing floors and warehouses are flooded with paper today. And the third stream of paper that we still see everywhere is log sheets. What are log sheets? Okay, you write me down every hour the temperature, the pressure, because I want to make sure you paid attention. You're awake. You're keeping an eye open. And so you write it down. Then we are sure we're monitoring the game. So I would say part of instructions are stuff to read, to know, before you go into the action. And the other part is, while you're doing it, please register, please log, or have another look that you do it the right way, first time right. And then the work order, that's a different ballgame. Work order is simply telling them what needs to happen right now, be it a repair or be it a production. Now, devices. What is the right platform to use? If you read stuff, don't use a Google Glass, don't use all of these nice, smart eyewear that you can see here. You have to sit down to read. Look at your terminal, look at a tablet, that's fine. That's stuff to read. But when you're in the action, not reading needs to be done before you enter the floor, but when you're entering the floor and you need to log some things, or you need to follow a specific step-by-step sequence, and we want to make sure that even you're supposed to know it, you go step by step, then you need to do two things at the same time. You need to do your work, and you need to capture information. It means you need to, what we call snack, like fast food consumption. You need to snack information in a blink of an eye, and you need to be able to log. And there is a big advantage to have your hands free. So here, okay, a tablet and a phone, but then you have to put them down and sometimes put them away. A glass is easier. A watch is on your wrist and is also easy. So snack information and log information is the essence of where Google Glass, where the OptimVents and all the devices, the Moverios and so come in. So the case in business, there are plenty of cases. There are plenty of cases, it's always the same. It's helping the deskless worker mobile and hands-free, paperless, make sure he did it, prove he did it, so compliancy, first time right, and then don't do twice an input, do it once, so make sure it's integrated. And that can be done in quality control, it can be done in maintenance, asset inspection on the manufacturing floor, field services, logistics, everywhere. The question is now, how are we going to empower that deskless operator? The first thing, I have one here, for those that are not familiar with it, this is a beacon. Most known maybe, if you know it, Estimate is one brand that is quite popular. And what is a beacon? The hype was more in marketing. It's a device, you stick it here, it sends a signal. It doesn't do anything than sending a signal every X seconds or milliseconds. It's me, it's me, it's me, it's unique. And when you move by with a phone or another device that has an app that is designed to listen to this one, not to another one, to this one, then suddenly that device wakens up, goes to a server and says, I just heard this one shouting, it's me, and then the server says, okay, now I've got news for you, tell him to stop, or tell him to do this. So this, I would say, primarily a marketing device because for promotions, sticking it on the shelf and giving you a promotion on a pizza. No, it's interesting when you stick it on a machine and the technician walks by, he doesn't need to tell you he's at the machine. This thing is telling you he entered the parameter of the machine. And so what is the primary function or the primary functions in industry for this device? It is twofold. First, indoor location, because GPS in an iron and brick building doesn't work. It's not precise enough. So it gives you a precise location. Don't tell me you were in the room. I know you were in the room. And the second one is that it's proximity detection. You're approaching me in less than a meter, and so you don't have to scan the code of this machine. We already know you're standing at the machine. It's saving a click. Is this the top priority in instruction management? No, it is not, but it is definitely something that can make it a little bit more lean, saving a click, saving a scan, and add to the performance. But it's not the first one I would put on the list. The second thing is, okay, we heard a lot about contextual information. You're doing a checklist or a procedure, check this, do that, and then at a certain moment in time, the guy needs to be informed on something. And we came up with a kind of quite generic solution, what we call an Internet of Things card. What it does is, it tells at that moment in time, the server, the cloud solution, tells the app, go to that URL with that secret key, with those information, who is doing what, which procedure, which case, which machine he's standing on, send that to that page, and then, depending on the situation and the client, that page can give him something back. And that can be anything. It can be the weather forecast for tomorrow, double check the isolation for a certain pipe. It can be a monitor that streams constantly temperature because he needs to take a closer look. It can be anything. And that is connecting the guy, the lady, whatever, the operator, to the Internet of Things during his instruction. Now we come to the glasses. I found it very difficult to make a statement about glasses, so we came down to a kind of a taxonomy to frame the mind, and we come up with 5 different types of glasses. And I think so far, everything I've seen out there for the last couple of years fits into this picture, still fits into this picture. Glass cameras, it's the GoPro in a glass. No more, no less. It just captures what your eyes are seeing. There is no display for a good reason, because your eyes need to be on the real world. If you're going down from a canyon with your bike and you like to have your friends enjoying the death road you're taking, you don't want a mail coming in. It would be the wrong timing to consult a mail when you're that far of an edge. So there is nothing than a camera. The second one is the smart rear mirror. The Google Glass is the perfect example. It is a little display, the Vuzix is another one, a little display hanging in the corner of your field of view. Why in the corner of your field of view? Because you want your eyes on the reality. So it's not augmented reality, it is focus on reality and then have a little information in the blink of an eye in the corner of your field of view. I call this informed reality. Then the third and the fourth category is different. Now we are talking most of the devices and certainly the binoculars. It's a very crowded space with the Moverio, the HoloLens, the ODG, all these devices. Your eyes are forced to look through an optical engine. And on that optical engine, there is an overlay of digital information on top of what your eyes are seeing. You can have it monocular and you can have it binocular, just a broader field of view. And then the last one is immersive eyewear, which is the Oculus Rift as an example. It's abducting you from reality, plunging you in a virtual world. Now, for instructions. What to use? We come up with this generic graph that tells you two things. On the horizontal axis, there is the enriching of your natural view, feet of the mind. On the vertical axis, there is the view on the world and the vigilance of reality. And it's communicating. At the extreme point there, you have the virtual reality. The feet of mind is to the maximum. But your view on the real world is 0. On the beginning of the horizontal axis, the GoPro in a glass, Pivot Hat is a quite known brand, that has no display whatsoever. You're just looking at the real world. So the field of view on the real world, the vigilance is 100%. But the enrichment on top of what your eyes are seeing of the real world is 0. And so you go down from full eyes on the real world to 0 on the real world and fully indoctrinated by a virtual reality. If you're talking instructions, and this is a key message, if you're talking instructions, for education and training, virtual reality is perfect. Augmented reality might even be better, because then you can sit down, you can try it out without doing it. But when you're standing at the machine and you're drilling holes with the machine or bending metal sheets, you want your eyes on the machine. If not, you could lose easily a couple of fingers or a hand within a couple of seconds. So even from a safety perspective, the cognitive load must be minimal. Are you going to be maybe distracted with a very painful outcome? So there in the, I would call it Pareto-wise, 20% of the complexity, but 80% of the use cases in industry is, I would call it in instructions, simply informed reality. Okay, let me look at the machine, but yes, if I have to know something like the rear view mirror in your car, it's there all the time. You use it, 20 seconds while driving for an hour? But you need it. Sometimes it's going to save your life. But if you look constantly in the rear view mirror, you're going to have plenty of accidents. That's the whole idea of the smart glasses. So yes, they're all used for instructions, but some of them for training and education, and others for guiding you during the execution of your task. Last point is the integration. So there is a wearable platform connecting your glasses, your watch, your mobile phone, telling you what to do. And as I explained with the maintenance person, check me this temperature every hour, check me that pressure every day on a compressor. You are doing it on paper. Integration of paper is 0. So is there an integration problem? Well, is there an integration problem today? It's all on paper. So there you can directly communicate to the wearable device and tell them, okay, fine, do this now or do that now. But part of the, to come back to the maintenance guy, part of his work is also repair and maintain shutdowns, for example, machine revisions consuming spare parts. That part of his activity is managed by enterprise resource planning or enterprise plant maintenance modules, Maximos. And so there, the whole thing, the backbone of what he needs to do is managed by these ERP systems. Now, if he's walking with a mobile phone in his pocket or walking with a smart glass on his nose for this replacement of paper instructions, the natural question is, he's wearing the glass anyhow, can't we bring also the work order, the repair order, the shutdown planning, can't we bring that also on the glass? So there is a natural demand for integration with the backbone and to make sure that he exploits the wearable device to the maximum extent. Just as a summary, I'll take our own platform as an example. Our Proceedix platform that handles all of this, and I would say in a quite pragmatic way, it leverages cloud computing because that's the advantage of in the cloud. Yeah, you scale it easily. It has the Internet of Things connectivity. So yes, you can have the weather forecast when it's relevant. The mobile thing, I would say roughly, and certainly in Europe, 95% is still on mobile, if they have mobile, because most have paper. Then data analytics, it has been mentioned, a huge potential it's created to do statistics on top of everything that is registered now, because everything is logged. Some call it Big Brother, but yeah, where you're standing, when you started, when you stopped, we all know it. Then there is the wearable thing, one comment there. What works on a wearable works on a mobile. What works on a mobile does not work on a wearable because it's a different UX. What you see there in the little corner is not the same as what you have in your hand. So it's a different UX. And leveraging the mix of things, that's also an important message I want to give, is that it's a mix of things that brings a solution. It's not one glass, it's not one type of glass, it's not just beacons or another, it's the mix of things where you can combine a glass with a ring scanner, for example, or directly connected Bluetooth with a sensor, a measuring device. It's the mix of things that will bring a solution for the worker, and it's only the solution that is of interest to the worker. The technology is just a way to get there.